Welcome to Summit. So what we're gonna do today is explain to you how the mantle is actually to be calibrated for the different uses that you will be working with. So the mantles work off a hybrid operation, so they can actually sense temperatures from multiple locations and operate based on that. Here we have our test bench, what we calibrate against. So anytime someone brings us a product, we were able to go up against the standard, and we have every one of these units here standardized. So what's really important is that you can take a bunch of mantles from all different manufacturers and you actually put them side by side, and none of them are accurate. One of the ways that we are going to try to teach you guys how to calibrate something is by embedding the use of a traceable thermometer of such. So we use a traceable brand thermometer. I actually have a particular unit that I hook up to this and I can calibrate. These are pretty close, but not all that close. What we do here is we purchased a Reed, fully certified with a certificate thermometer with a certified probe. Now, as you can see, these probes are just like little wires. They aren't very robust, but they're very accurate for immediate temperature results. So I'll generally take this calibrated unit and put it in something that's hot, and once it's stable, I'll throw this guy in there and I'll run this on a daily basis. And I use this just to calibrate against, so I have an actual standard, but I don't wreck this thermometer. So that's why I use this unit on an everyday practice, and usually as customers purchase mantles from us daily, this thermometer itself is like $15.99 up here, and it will last for about a month of everyday use before that tip just breaks apart. So let's talk about how the mantles are set up. Factory, they're set up to run from the bowl, and there's a hack where we can run it from the liquid. So let's go over how that works. So first things first, there's two ways of setting this up. If you put the first probe from the mantle in the first location, you'll be reading from the bowl. If you put the liquid probe into the first location, you'll be reading from the mantle. So when we run it from the bowl, the customer and the user has to actually recalibrate the unit for the bias of the difference. And I'll explain what that means here in a second. Also, typically, if you run it from the bowl, you will encounter a completely different type of temperature range. It's not how you normally would see. So import mantles or typical mantles read from the liquid, and what happens is it reaches the temperature, it chases that temperature until it hits it, and sometimes there's a little bit extra heat, but it's right about there, it's in the same zone. That's what people are used to seeing, is right when it gets to liquid temperature. If you're doing something really precise, you'll actually run it off the bowl, some sort of reaction where you can't go over temperature, but the bowl temperature will always be higher. So the liquid temperature will be lower. As an example, if your bowl is set to 150, your liquid will usually never go above 138. So that's what brings us to the next point, is how mantles operate. Most mantles just dump heat out until it sees it at a certain point. Ours actually monitor it. And let me explain what happens first of all. So if you want to be at, let's just use this color here, 150 here and 150 on the liquid side, you're going to have heat around your mantle on both sides, and it's always going to be hotter than the 150. Usually when you're ramping to temperatures, you'll see something maybe around, on both sides, between, to get to 150, 230 to about 450 or so. It really varies, and how long that 450 is engaged for is a very short period of time. So what will end up happening is when you hit this temperature, and let's say you stabilize, you'll usually be right around 160 on the bowl to about 170 at an average of 165. And that's how hot the bowl must remain at any given time for the center of the system to see 150. So what happens is, in this case, with the bowl, heat is generated around the entire location, but where it sees the heat is almost instantaneous. So it drives the heat zone right up to where it needs to be at, and then it brings it back down. Now, that can be kind of tricky, because if you're biasing the system, you would normally have to say if that temperature is at 150 but everything here is hotter, you would reduce that temperature in the bias. You'd subtract it off the system, so if it's at 165, it thinks it's at 150. And that's how you mate the bowl version of the temperature. With liquid, you're actually going to be at 150, same thing. Now, the way that this system works is it generates an abundant amount of heat. The program in the system is actually very unique to how it generates heat, but it works much more efficient. So a really good example is this side of the bowl. When you're running it, you will run roughly 400 Celsius when it's ramping up into temperature. And it takes about, I believe, as an example, 45-minute plus minus for you to hit your desired temperature. So it generally stays hotter when it engages, and it stays hotter. This side on the liquid, when you are putting heat on it, actually runs at about 350 Celsius, and it takes about 20 minutes. So this was also calibrated on a 5-liter mantle for these times, and it was without any aggressive tuning or PID settings. So we're just doing an actual standardized test. What we found was running from the liquid with our mantles generated less heat and longer intervals and brought it to temperature much sooner. Running it from the bowl, it was much more heat, further apart intervals in the system, and it took longer to get to temperature. Now, this is just a choice depending on how you want to operate it. It's completely optional. Most users just want to hit it and set to the liquid and go from there. And this way is the actual easiest way to calibrate the system. That method right there is a little bit harder because when you're operating the mantle, you have to remember if you set the temperature at, say, whatever, an example of 200 Celsius, and you're pulling a really fast distillation, this temperature right here will be more close to that 400 side. It's going to retain a lot of juice and keep it warm for long periods of time, so this temperature doesn't go down from subcooling. So the same thing, it's basically on both sides the same way. Now, what's the difference when you run it? The difference is on the PID setting, your first PID is going to be, let's see if I can get this. So if you're running with the bowl, then your main temperature will always be right here. So this is where your set will be, and this is what it is. And the same thing, usually the jacket, that one doesn't change. Now we have the liquid side. So now this becomes arbitrary. I'm sorry, this is the alarm. And this becomes arbitrary, which means that whatever you set this point at, this will tell you what that temperature is, guaranteed without a doubt. And then right here you have your vapor. You have your alarm, and you have the vapor temperature. This is the exacting temperature. So if you switch the probes, what's going to happen is this is your set point will actually be liquid. So the liquid probe gets changed, and now it's reading from the liquid side. This is actually really unique because there's no other mantle that has this next feature. When you switch the jacket on everything, when you switch the mantle bowl back to the liquid side, this selector where you'd normally see the liquid is now going to give you, because you have an alarm here, is now going to give you the definitive answer of how hot that bowl is. So when you're distilling much faster, this number, this is going to be live. This is a live reading of the mantle. That number is the actual temperature of the bowl. So if you're at temp and you're only seeing a 30-degree difference between the bowl and the liquid, that's telling you that everything's running pretty smoothly. If you're distilling really, really fast or pulling a lot of solvent off, and that number is like 300 or 400 or whatever, it just means you're pulling a lot of energy off. So this will tell you how fast you're pulling based on how much wattage is setting in the system, which ends up being in temperature. So now people always want to say, well, how do I calibrate this to my needs? I really think personally, the liquid side is going to be the easiest one. Now, I'll just use both of these as an example of how I would do it. I would take a cold trap and I'd use vacuum pump oil. On a brand new flask, you can reuse the oil, it doesn't go bad, it actually cleans it up when you do this. And there's about a half a cup to a cup of water, sometimes an average amount, I'm not really sure, but there's quite a bit in there, and that creates a reactive oil, so you want to pull vacuum on the system. I just take a basic cold trap, throw it on this. In this instance, to do my calibrations, we have a different setup here, but I'll explain is what you would do normally. So this will be an example with the well, and the reason why the well is different is because the well will always be a couple degrees difference than putting the liquid in there. So let's say you have a well in here. And now we put the probe. You just need one at first. You really don't need to do anything else. You could use more, but you're only testing against a single standard, so you only need one probe. Okay, so essentially what we would do is install the mantle, put the liquid probe into the first port because we're going to read off the liquid probe. We then will do an auto tune. This is primarily used just to be sure you have the most amount of power kind of gauged to your zone. If you want to auto tune to a higher temperature, you will have more power at that higher temperature. If you auto tune slightly lower, you'll have a medium amount of power. It's still a lot of power, but you'll have a medium amount of power. It's not just dumping voltage out. What I normally do is auto tune to 150 Celsius. And by doing that, if you're at 175 or 200, if you set it to a high temperature, it's not entirely just going up there and dumping out so much energy that the system overheats. It's actually dumping up as much energy as it would need to get to about 150. But it's really accurate that way. So what I will do is I will turn the system on, and I will first just go to 100 Celsius with a liquid probe in there, and all the biases are set to 0, and I just straight go auto tune. So I press auto tune immediately. All right, and that just brings it up there, the jacket and the bowl. Once that auto tune is pretty close, I mean, like it hits to 100, and because what happens is it goes back and forth and it becomes a little bit useless, but you just want it to get to where it needs to go. So right around the time when it hits 100, I'll just go straight to 150, and it's still doing the auto tune sequence. So I let it just do its thing. It'll go up and down, and at this point in time, it can take quite a while. I've seen some of the larger mantles take like 4 to 6 hours to complete this. On a cooler room, it's a lot less because what happens is it purposely goes up and then down and then up and down. It basically runs a circuit where it comes up and gets smaller and smaller, etc. And then it dials itself in. So I always run vacuum because I want to pull all the water off the system and make it inert. So you just hook up a diaphragm pump to the system. And you gotta be kind of careful because it will overboil. You'd be surprised how much fucking water is in a bucket of pump oil. So once it's around 90 or some Celsius, maybe a little bit less, the water just goes away, the bubbles go away, and the spinner is just rocking. I'll pull vacuum on the system from the top. I'll cap off the rest of the ports, and I'll just let it run under vacuum until all this procedure is done. Now, once this procedure is done, and the auto tune is completed, basically what I do is I go from there, I will go to my average vapor temperature. So people think that they run 160 vapor or 180 vapor or 174 vapor. You go to 174. And that reason is because you're going to calibrate the next standard to 174. Let's just say you want to be at 185. So whatever, 185, and you calibrate to that standard. So what happens is I'll just go up to 185. Now I've gone to temperature and I see, oh, everything's like within a degree, but everything's there, it meets up. So I go to 185, and then all of a sudden I'm at 185. So the next procedure is as follows. You take your thermometer, and what you do is you then plug in your vapor port. So you're gonna calibrate everything to this number. That means I'll remove the trap, and I'll take my vapor probe, and I'll just sit it in there. A great example is like this. I don't know if you guys can see this. I just bend the wire, and then I put it over there. So now, when you're running this calibration, I put in my vapor probe, and then I'll put in my standard. And this is the standard right here. Let me label this for you guys. Liquid first, and this would be the vapor, and that's 1, 2, 3, 4 down. So what I have is my liquid, it's in the well, and you can use a regular one, doesn't matter, the well will be 2 degrees off, that's why this is very important to do. So I have it in a well, for instance, and I take my vapor, the one that I'm going to be using to run my system, and I put it in the oil, and then I put my standard inside of it. So you always turn on your probe, go to the decimal system, and then you enter into the menu, press 1, 2, 3, 4. Once you're into the menu, there's going to be bias, last page, etc. page. You click on the bias page, and literally whatever this for sure analytical NIST certified answer gives you, you then calibrate to the 10th of a Celsius plus or minus on all the channels, and then you bring it back down to a known standard. And after that, the system's ready to go. You can dump everything out, and you can continue on and do your shore pathing. Something to remember that's really, really important with this process is you will be dealing with multiple different types of thermometers and different types of heaters that are in action. In the top and the bottom, there's different technologies inside of them. The probes, even for the liquid that are encased in a stainless steel sheathing, is also a different type of probe. So I believe if you have a couple of issues with that calibration, like maybe a degree or two up, what you do is you lower the jacket on top down. And the reason for that is because the jacket responds extremely quickly, and it doesn't really need to be that hot. In some cases, when you're doing your heads, people will actually increase the temperature of the jacket and then chase it with the bottom, and that creates a turbocharge effect where the vapor comes out of the system without affecting it. So that's one option that you have to run when you're running the auto-tune calibration. It doesn't really matter. The auto-tune will be fine. It'll be within a degree. The only way to tune the jacket to an auto-tune is now taking your thermometer and taking the jacket off, and then putting it like a clam together with maybe a few towels to keep it isolated, and then just keeping the jacket together, and then you have the jacket's auto-tune will go on its own, and you'll have your own thermometer, and then you can calibrate the jacket to it. So here's some of the cool features, and this is the actual methodology of tuning. Now, if you do it the other way around, let's say their mantle bowl is attached to here, right? Essentially, all of this is roughly the same hookup. What you're doing is you get it to temperature. So I would put my thermometer in there after it's on vacuum, and I'd say I'd bring it up to 175 and just see what happens to the system, maybe 160. And then once the system itself stabilizes on its own with an auto-tune, I'll use a thermometer, put it in there, and then I set my deviations. The difference is that your deviation number for the bias on the mantle is going to be like anywhere from 7 to like -15. And the reason is because it seems the mantle's hotter than the core is. So you always have to be pushing that pushing the heat towards the core, and that's what happens is the outside's always hotter than the inside. With this hybridized technology, the mantle can actually run right off the liquid and tell you what the heat is in the system, so you kind of know what's going on with electronics. You can start seeing, like in 5 years on the road, if this number gets all janky, it probably means that the heater's going out. I mean, there's so many identifying purposes of this technology that it's just endless. So I hope you guys enjoyed the video. Our other one was a lot goofier. That one was based on the first methodology, which was based off of the mantle bowl. When you're done doing that calibration, it's the same thing. It's a bias change. Either way, if you ever screw up, you take a picture of everything and then go back in there, and you can just go straight to a new auto-tune procedure and then set. You can jump back and forth. All you have to do is set a calibration. The reason is because in both rates, you're not just you aren't just signed off once you calibrate that temperature. You have to calibrate the temperature to the process. If you aren't doing it, then the biases won't be set right, and it'll be jumping back and forth. I highly suggest to use liquid bias setting. It's a lot easier. It's really accurate. It uses less wattage. It uses less heat and then goes up in temperature faster. The other method is mostly for really expensive chemicals or really expensive reactions that can't overshoot or have to be within a certain threshold of a temperature. I hope you guys enjoyed this video. If you have any questions, let us know. These are our test and certified stations, so when you purchase a mantle from us, usually you'll get a call from me or someone on the staff, and we'll discuss this process with you just briefly overall, and we'll then do an in-house calibration and make sure it runs against a standard that we know. So when we're done with the calibration, we can go up in temperature and watch both units, your unit that you purchased and a bench test unit that's been calibrated, go up and at least meet at the same point, so we know that we're sending you out a top-notch product, that we're not just blindly sending you mantle and expecting you guys to do the calibration, which is fine. You're more than welcome to. If you want to, let us know, especially if you have a thermometer that you trust, that you know that's your 174 degrees Celsius on your vapor that you always want to use, then we're more than happy to send it out with a link to this instruction manual to show you guys how to do this. Thank you.